I'd like to introduce now Richard Sasson, who is the Global Director of Training at Crestron. Richard may be known to a number of you because he has gone around the world with the training. So without too much further ado, I'd like to bring Richard out. Richard, can you please join us?
Well, I'm glad to be here, and I'm glad to see people in the audience. It's very exciting. I got that wonderful introduction. Yes, I'm Richard Sasson. I'm the Global Director of Training for Crestron. And we're going to talk about securing and security on AV components in the network. And it's an important thing to understand. A lot has changed over the years, right? Many, many years ago, you never thought of putting an AV device on the network. Well, now we do that. And you know what's incredible about doing that is we've ended up with lots of cyber threats because of these types of devices. In fact, there was a gentleman, Paul Konewowski, who created an article in 2019 in Commercial Integrators magazine, and he identified one of the biggest threats in the corporate network, believe it or not, are unsecure AV devices. And these AV devices can easily be scanned and found out on the internet web, and you can actually identify ways to get into corporate networks because of it. And he identified, actually, that you could identify these vulnerable products by searching NIST National Vulnerability Database and the advisories issued by the Industrial Control System Cyber Emergency Response Team. These types of devices are easily accessible and open up a vulnerability to corporate networks. So you want to take that into consideration as you begin to deal with cyber security. So it's no longer just about putting devices on the network, but really to understand what you need to do from a cyber security perspective. And when we talk about cyber security, it is really easy to get caught up in the alphabet soup, TLS, HTTPS, 8021X, all these wonderful acronyms you need to learn and understand about security on the network. But ultimately, what is cybersecurity? And what is security of any sort? And ultimately, what we're talking about is the dictionary defines security as freedom from harm. Okay? And even in Latin, it was defined as securus, which means freedom from anxiety or care. So we can extend out toward protecting things that we care about from harm. Cybersecurity specifically refers to protecting electronic information from harm. So how can information be harmed? Well, it could be exposed to someone we don't want to have access to it. It could be modified so that we can no longer trust it. And it could no longer be available to us. Those three items, when it comes to being exposed, we want to maintain its confidentiality. When we want to avoid it being modified, we want to maintain its integrity. And of course, when we want to have access to the data, we want to maintain its availability. Those three items create the Cia Triad, and that is not the American Central Intelligence Agency. That is dealing with confidentiality, integrity, and availability. Those three items are the principles and the most accepted model in the IT industry for maintaining security on your systems. Now, there's some other models that have been proposed. They really haven't caught on, so that's okay because they all rely on that same three-item subset. Now, why is this useful? It's a way to break down cybersecurity into subsections that are understandable. What is also important is non-repudiation. This is a way to validate and authenticate that the data is a trusted model. So we have many tools available for cybersecurity. We actually break down our confidentiality is mostly maintained by two key elements: authentication and authorization. Now, authentication determines who I am, and authorization determines what I can do. Authentication includes things like passwords, biometrics, cryptographics, pass cards, keys. They're often combined with multi-factor authentication things. I'm sure you all love the fact that now whenever you go to your banking site, you have to multi-factor authenticate that it's actually you, even though you're connecting in from your phone, right? That's part of what we're talking about here, is making it ensure that the people who are connecting and have the right confidentiality. Now, data integrity can be maintained in multiple ways. It, of course, overlaps with the confidentiality, okay? But you want to make sure that you can't alter the data you can't access, because that's an important item. Now, we have other tools at our disposal as well to detect when data has changed, using checksums or hashes. It's also as simple as restoring a well-known state with a healthy backup plan should something happen to protect your data. And some real-world examples of manipulating business data affect decision-making, or falsifying banking records, or siphoning off data. So these are important things to understand why AV devices need to be secured, because people can do these wonderful things. And of course, availability is critical as well as having access to the information you need when you need it and when you want it. So without ensuring your system is secure, you will have challenges doing that. Okay, so now let's discuss some key terms that are used in cybersecurity. And most of these are pretty much everyday terms. There's nothing really particularly scary about them, but it's understanding what they do and the slight nuances. For example, asset. As we noted earlier, these are things we want to protect. It's something of value that you are trying to maintain and keep secure. A threat is a circumstance or event that could cause harm to your asset, okay? And what someone might steal sensitive data, keep us from our data using things like ransomware. These are things you need to be aware of that can happen. Cyber threats are specifically initiated by a person or an entity known as a threat actor. And this actor is definitely not going to get an Academy Award. So keep that in mind. This might be a cyber criminal, a hacktivist, a competitor, a careless or disgruntled employee, or maybe even a nation state attacking a system. Believe it or not, we see these all the time. Vulnerability is an identified weakness, but by itself, it's not necessarily a dangerous situation. It is possible for a threat actor to take advantage of the vulnerability, and that there's additional cause for concern when that happens. Examples of vulnerability could include cross-site scripting, SQL injection, server misconfiguration, non-encrypted sensitive data, and so much more. So you have a lot to look for. But ultimately, an exploit is an act of leveraging a vulnerability. It can take advantage of a single vulnerability or a possible chain of events taken together. And when they indicate an exploit is taken care of, we want to make sure that we assume that the safeguards around us have already failed. That's an important thing to keep in mind when you're dealing with security. Never presume your system is secure. Always presume there's a point of failure in it. Now, risk. This is an interesting one, because this is your potential for loss or damage, but sometimes it's a misunderstood perspective. The risk is how everything plays together in this scenario. And a breach is the actual scenario where something has occurred and your systems have been infiltrated. So you need to keep that in mind, and that is a concern. These key terms are what you're going to want to interact with when you're discussing security with the company's IT administration. So keep that in mind as you are moving forward and dealing with these things. Okay, so now that we understand the basics of those terms, okay, for each bit of data, we want to make sure that it can be protected. At the end of the day, it's all about analyzing the data that are in our systems. Let's look at each piece of data available and first determine its value and how it needs protected. Some data, like credentials and signing keys, require more thoughtful consideration than, let's say, the company logo that goes on a touchscreen, for example. Now, don't get me wrong, the company logo is an important item, but it's going to be a bad day for the InfoSec team when you walk into the space and all of a sudden on that touch screen, on that computer, you've been hacked. Your logo's been graffitied. your meeting's been compromised, okay? All of a sudden, we need to maintain information of the data and integrity of a system, and it doesn't mean that it's confidential data. It could be public data, such as the logo. It's not just about usernames and passwords and GDPR compliant information. It's about making sure that your systems are still secure so you are not impacted during your work environment. So let's consider the answers to a few of these questions. Who can create signing keys? And signing keys are important components of ensuring the data stays properly protected. There may be a whole chain of trust involving creation of these keys and security providing to the person who's doing the programming. In this case, we want to make sure that those folks are most likely the same people. If they're doing the programming, the configuration, they probably have the right administration rights. But they might also be people who are reading information or getting information from a system. They might have different access and may not name the same type of keys and information to access accordingly. In all these cases, we can use authentication to identify who are the various users and what they are allowed to access and how they can access. Ultimately, most likely your administrative group are going to be the ones who are going to set that all up. And what we're going to talk about a little bit is, where does the data need to be protected? When it's at rest? When it's in transit? Both? Let's start by looking at how we're going to secure our data at rest. First, let's discuss what do we mean by securing data. Well, when we talked about our Cia Triad, we want to make sure that we are having information that is read by authorized individuals. That's your confidentiality. We want to verify the source of the data and ensure it hasn't been modified. That's your integrity. Availability in this case is connecting back to ensuring some unauthorized entity can't remove the data, so its confidentiality is still at play. We use two methods to secure data at rest. And we use encryption and authentication. And back to our example, we want to make sure our keys are encrypted on whatever storage is being used. Otherwise, for example, a threat actor could go to a device, remove an SD card, and now all of a sudden has all your information if that SD card was not properly encrypted and protected. So these are important things if you're bypassing threat organization by using clear text on important documentation that you want secure. You want to avoid that. So there are top 5 product features, securing data in transit. The following actions are needed. We want to ensure the data cannot be read while it's in transit. Now, we must also verify that both the sender of the data and the receiver of the data are correct. So if I'm a device sending information to a receiving device, are those two devices the two devices that should be receiving the information? Again, both confidentiality and integrity come back into play. If we go back to our example, we have the keys, which are exchanged between two entities, and we want to say, how do I trust you? That question gets bigger and harder when we start talking about moving data in transit. At rest, it was one thing, it was authentication and encryption. Now, we've got to look at different cases. There could be a man-in-the-middle attack where our data is in transit and someone wants to intercept that data and do something else with it. They want to convert it, they want to corrupt it, they want to inject something that's going on, a ransomware or otherwise. To have secure data, we need a secure encryption key transfer. It's a bit complicated and a bit of a recursive problem, but that's okay. In creating systems, we need to also keep threats in mind so we can design a solution that makes business sense. If you secure your system so it's so secure that no one uses it, guess what? That doesn't accomplish anything for you. You want to make sure that you secure a system and it is continuing to be usable. For example, in creating systems, we need to keep various threats in mind. And if we look at our most common secure protocol, it's TLS. And we must make sure we understand which of its many options we are using, for example, as there is a cipher option, which provides great integrity, and it uses an SHA 256 hash of the data. But in those cases, it actually has a null, which represents unencrypted data as well. So you have to keep that in mind in understanding of that design. Most TLS connections only authenticate on the server side of the connection. Why? Because if your client and your server are both connecting to each other and you have multiple clients connecting to the server, you might overwhelm the server. So the client might use an application authentication to ensure that it's properly encrypted for protecting your data. And this is used all the time in web services, and it's common practice to create an API key that can validate the server and the client accordingly. So, top 5 product features. Things to take in mind as you are designing your systems. You want to encrypt your keystrokes, your audio, and your video content. None of this should appear in clear text format on a secure network. Encryption converts AV and USB signals into obscure code to prevent unauthorized access during transmission. Secure command and control, how devices communicate with each other. These need to be encrypted, for example, using HTTPS to prevent man-in-the-middle type attacks. User authentication and passwords with Pro AV devices are important to ensure proper, secure communication between your devices. For HTTPS is going to run over that Transport Layer Security Protocol, or TLS connection. TLS is an industry standard for secure communications over the network. It is an improved version of Secure Socket Layer, or SSL. TLS uses asymmetric encryption for both public and private connections to protect the transported information and relies on digital certificates to validate the identity of the transmitter and receiving devices. Now, the command and control layer can use authentication and passwords to ensure communication, okay? User permissions are also important. What are they allowed to access? How does your device then authenticate within the system? And of course, you want to make sure that your systems are able to do proper firmware and software updates, and you're not loading a firmware to a device that is not properly secured. Is it approved by the manufacturer? Is it from their site? Did you pull it off from some other site somewhere else because you couldn't get it officially from their site? You only want to install proper firmware and software from vendors accordingly. Okay, clear text, we talked about this. You don't really want to use clear text. It makes you very vulnerable. Okay, it is something where all the data you are transmitting is identified. That means anyone can hack it, anyone can see it. Anything you use on clear text should really, again, be minimized and avoided, but specifically do not show passwords, do not show usernames, do not show encryption keys, do not stream passwords, do not show your IP addresses, your source destinations or routes. This is critical to ensure you have a secure environment for your devices. Now, HTTP directory and listing field visibility. Software control on the network. This is important. You want to make sure that your systems do not have directory names that are exposed. The data should be hidden and not visible on the network from an IoT device or an AV device because it creates a target for attack. Even simple things like benign directories allow people to get more information than they need. Sometimes it's the name of a directory, that's something they're looking for, or something they're not looking for. So avoid that exposure, make sure systems are not available. Cross-origin resource sharing. Now this is a browser standard, and as a browser standard which allocates for the resources and functionality of web applications to be accessed by other web pages and other applications. This is a critical component for what you need and what you want to do for security. Now something that's really simple, password authentication and complexity. A lot of people have wonderful passwords. Password 123. Okay, those are not real passwords. People use it all the time, but guess what? Those are really vulnerable passwords. That increases your risks, that increases your vulnerability. How are you addressing your passwords as standards on your systems? How complex are they? How many characters are there? Are they alpha, numeric? Are they at least special characters? Are there capital letters included? What are you allowed to do? These are important things. What's your minimum number of password characters? Keep that in mind. Your password management. Do you change your passwords every 30, 60, 90, 120 days? What do you do for those items? Do you do a lockout on your systems? Ask those questions as you're designing AV systems that sit on the network. Then think about re-authentication. When users change, how do I make sure that the devices are secured when somebody else comes into the system? In addition to that, should I add in multi-factor authentication with my devices? Also, understand certificate terminology, from root certificates to certificate authorities to self-signed certificates to, to intermediate signing certificates. All these things play into mind, and a great place to look is RFC 5280, a great platform. Understand that. You want to take a screenshot of that. This is where you get your official standards. Port security is incredibly important. Make sure things are locked down and secure. Firmware updates we talked about. Network segmentation. Take the time, properly segment your network, either with a VLAN or a physical lockdown network. Okay, and then here we go talking about VLANs. These are really important for you. All traffic for AV should be separate and on your virtual LAN. Now, physically separating networks, this is another option. You can actually have a dedicated AV network separate from the main network. Or the other fun thing you want to do is make sure you're capturing all of your system logs and information. And make sure that your components are being audited on a regular basis. What's my vulnerability? How are things being affected? How do we make it all come together? And that's about it. I believe I'm out of time. I want to thank you. I hope you take the time to get secure systems going. Appreciate it. Take care.